So look at data modeling in Power BI. So let's get down to brass tacks. So first things first, what is a data model? So a data model is a way of organizing and structuring data so that it can be stored, assessed, and used in a logical and consistent way. In other words, is a visual representation of an organization's data elements and the connections between them. So it shows how entities like tables are connected together and how you can use this to create reports, dashboards, etc. So this image here just gives us an overview of the sample data model. This looks a bit complicated. So data models can be simple and they can be quite complex. So it shows you different entities. These are different tables, and you see all those lines that show how they are all connected together. So data model just helps structure the data. It's like an abstraction or a semantic layer that shows how the different tables are connected. And this way you can use this to understand how your data your data tables are connected, and then use this to do your analysis in an efficient and effective way. So let's look at data modeling in Power BI desktop. So in Power BI, it involves creating relationships between different data entities and using these relationships to create a data structure that can be used to build reports and visualizations. So in Power BI, you have entities, which can be tables. You create connections between them, and you use this new connected tables to build reports and visualizations. So this image shows us a sample data model in Power BI. So once you build a data model, this is what it would look like in Power BI. And it's similar to what we saw previously. You have different tables. Here we have 5 tables: products, location, date, customer, and others. And you can see these lines showing you how the tables are connected together. So why is data modeling important in Power BI desktop? Now, the first reason is it helps you organize data efficiently. So you have a visual representation. So if someone comes into the organization newly, maybe someone joins data team, for example, he can look at this data model and understand how the different entities are related and connected together. So it helps you organize data efficiently, and you can translate this to different people. Even people who are less technical can also explain to them using the data model how tables are connected and how you can use this to build reports and visuals. Then it also helps to create accurate dashboards. So working with data models, right? As long as you follow the best principles, you find that it helps to ensure your data is accurate, and you can use this in turn to build accurate reports and dashboards. The next point is it helps to maintain the integrity of data. So this is similar to what you have in database design, right? You have constraints. You connect a primary key to a foreign key, for example. It helps to ensure that you have integrity of data. You're reporting the correct figures, right? It's similar to what we're doing in Power BI also. You create connections and constraints, kind of, and this helps to ensure that you're reporting true and accurate data. The next one is a reduced data redundancy. So as we'll see subsequently, in tools like Excel, for example, you might have one large table and use this to create your reports, right? But data model, you try to convert that large table to smaller tables that are connected together. And this way, you have a central table that holds the facts or measures you're reporting on. And then you have what is called dimension tables. I'll talk more on this later on. But you have dimension tables you can use to summarize your facts, right? Describe things like date, for example, or things like products or customers. Those are like dimensions. And you have your facts, which can be sales amounts, quantity, etc. So you break down a large table right? And a large table design, you find out that you have all the fields in one table. So it means that for every new entry, you have to update all the records and you're duplicating entries, right? Let's say customer A buys a product today. I come to the table, I'll put the time he bought the product, I'll put his name, I'll put his email address, I'll put his age, right? But this same customer has bought things previously. So there are some fields that I don't need to impute if I build a proper data model. I just do it once and that's all. So it helps to reduce data redundancy and repetition of fields. And then it also helps to improve performance, right? So data modeling, once you do it in the proper way, right, you find out that it leads to gains in your performance. Your reports load faster, and you find out that your end users would end up using and consuming your dashboards without much hassles. And then lastly, you can create what's called measures and calculated columns in Power BI. So I won't delve into this for now. This for subsequent lectures. But measures and calculated columns, they are fields that help you to further slice and dice your data, and you can carry out more complex calculations using measures and calculated columns. So let's look at some key concepts that will help us better understand data modeling. So we'll look at the components of a data model. We'll look at schema design. What is schema and how to design a schema? Then we'll look at normalized and denormalized models. We'll also look at relationships and cardinality and how it pertains to data models. So let's look at the first concept, components of a data model. So a data model has some key components. So the first one is an entity. An entity is simply a person, a place, a thing, or a concept about which data is collected. So for example, in a customer database, right, you have a customer entity, and this can hold information about customers, right? Customer names, customer email addresses, customer phone numbers, customers' birth dates. So an entity is just it can be a place, location, it can be customer, it can be product, right? These are all different entities that you can find in a typical data model. And then the next component is an attribute. So an attribute is a characteristic of an entity. So earlier I mentioned a customer entity, right? Things like the customer's name is an attribute, the customer's email address an attribute. So entities, their characteristics are called attributes, right? So name, address, phone number, these are all attributes of a customer entity. In the same way, if you have a product entity, a product can have a category, that's an entity. It can have a segment, it can have a unit price. These are all attributes of that entity, right? So let's look at the next component, which is relationship. So in a data model, right, you have different entities. So I've mentioned customer, for example, I've mentioned products, you can have location. So these different entities, they have certain connections, right? And these is like common fields between these different entities, right? You connect them together, and this in turn leads to a relationship, right? So for example, if you have a database, right, of customers and orders, for example, so a customer will typically place an order, right? He can place one, two, multiple orders, right? So how you connect the customer entity to the orders table is via a relationship. There'll be a common field. It could be customer ID, for example. The customer ID on the customer's table, you link it to the customer ID on the orders table, and that establishes a relationship. If you're familiar with primary and foreign key concepts in SQL, the same thing, right? You connect the primary key of one table to the foreign key in another table. That's like a relationship. The same thing in Power BI also. So you create relationships between different entities. And the last concept is cardinality. So I'll talk more of this in a bit. But for now, right, just know that it's the number of entities that can be associated with one another in a given relationship. And you have three main kinds: one-to-many, one-to-one, or many-to-many. And I'll talk more on this subsequently. So let's look at the next concept, which is schema. So what is a schema? A schema is simply a structure that represents how data is organized in a database. So a structure that shows how data is organized in a database. So it can also be referred to as a visual representation of the structure of your database, showing how your entities, attributes are all related together, right? So you have two main kinds of schemas. You have star schema and the Snowflake schema. So let's look at this in detail, the star schema and Snowflake schema. So the star schema is the type of dimensional data model where you have a central fact table and a number of dimensional tables. So now, what is a fact table? So a fact table are tables that store observations or events. So they store things like sales, for example. So let's say, for example, you have an organization, right? Or a sales team, for example. I want to make a model for a sales team. So the fact table, this kind of model, will track things like sales, for example, quantity, right? So all those things that are numeric and additive, things that you can add together, things that are numeric, these are stored in fact tables. Sales number, quantity, stock balances, exchange rates, temperature. Let's say, for example, I'm trying to build a model for a product analytics project, right? Things like website clicks, for example, that's numeric, right? Number of clicks of a website, those are all numeric terms. And these are things that you put in a fact table. So when you say fact, right, these are facts, observations, events, measures, things that you can add together. Then you now have dimension tables. Dimension tables now describe the facts, right? So they answer questions like when, where, who. So for example, I have a sales fact table. I want to know who made a particular sale. A dimension table will answer that question. And that's what's the customer dimension, right? So who purchased this particular line item? A dimension table will answer that question for me. When was this sale made? A dimension table like dates would answer that question for me. So you have a date dimension table. Where was this purchase made? A location dimension table would answer that question for me. So you have a fact table that has the actual business measures, right? And then you have dimension tables that describe those facts. So I want to know for this sale, who made it, where was it made, when was it made, and other descriptive attributes, right? A dimension table will help answer those kind of questions. So in a star schema, you have a fact table, a central fact table, and then you have dimensions that are connected to this fact table by your primary and foreign key relationship. And very important to note for star schemas, right? Every dimensional table is directly connected to the fact table. So let's see a pictorial representation. So this image here is showing us a sample of the star schema. And the name star schema, it comes from, if you look at this, right, the shape that this model makes is similar to a star, right? If you draw lines from every dimension table to the fact table, you have the shape of a star. The name comes from that, right? Star schema. So in this model, you have a fact table, fact reseller sales. If you look at the entities, look at the attributes, right, at the columns, right? You see things like sales amounts, product cost, quantity. These are all numeric additive terms, right, in the fact table. And then you have keys. all those keys is how you connect the fact table to the dimension table. So you have a dimension table called dim products, right? This is a dimension table that gives information about the product. So if I want to know which product was sold for a particular quantity or sales amount, right? I'll use the product key on the my fact table. I'll link it to the what? Dim product table, right? And that will help me return that results. The same thing too, right? You have dim sales territory. This is like location, right? So for this, you have key also, sales territory key. You link this to the fact table also. You have a sales territory key also. The same thing too, right? Dim employee, you have employee key and also an employee key for the fact table also. So the fact table has keys and then numeric additive fields, right? Like quantity, cost, sales amount. The dimension table now has attributes that answers questions like who, where, when, etc. This is an example of a fact table, right? A fact table, all the dimension tables are directly linked to the fact table. Very important to note that. So the next kind of schema is the Snowflake schema. And the Snowflake schema is similar to the star schema, except that for the Snowflake schema, the dimension tables are connected to other dimension tables, which are in turn connected to the fact table. So if you look at the star schema, right, all the dimension tables, they are directly connected to the fact table. But for Snowflake schema, you can have dimension tables linked to other dimension tables and now linked to a fact table, right? And the Snowflake schema is more normalized than the star schema. So normalization, I'll talk more on that in a bit. But then for the Snowflake schema, you have less redundancy in your data, right? So you have less repetition of fields. But then for the Snowflake schema, it can be more complex to query because you have what dimensions that join to other dimensions, right? So that would lead to more resources required to run those queries from this kind of data model. So let's see a visual representation of both models. On the left-hand side, right, you have a fact table. So you can see, right, the central fact table, and you have dimensions. They are directly linked to the fact table. But if you look on the right-hand side, the Snowflake schema, right, you see your fact table. Let me annotate. So you have your fact table here, right? Your fact table. And then you have dimension tables. So this is a dimension table, right? But you also have other dimension tables that are linked to this dimension table, right? So that's the main difference between a Snowflake schema and a star schema. The star schema, you have fact table and direct connection, right, between the dimension and fact table. But the Snowflake schema, you have dimensions linked to your fact table, and other dimensions can also be linked to that dimension table, right? So this is the main difference between the star schema and Snowflake schema. So I mentioned normalization previously. So I want to explain what this entails, normalization and denormalization. So normalized and denormalized models. So normalization is used to describe data that's stored in a way that reduces repetition. So I don't want to repeat fields over and over again. I want to build my model in a way that I can efficiently update it without having to repeat fields, right? So this is referred to as normalizing your data. So a fact table is considered to be normalized when it stores only keys. For example, a product key or location key or customer key, for example, right? So this image here is an example of a normalized fact table. So you can see that you have a product key, for example, right? But information about the product, for example, the product name, the product segment, the product category, I can't find them on the fact table, right? They would be on a specialized table, right? A dimension table. So I can now link my fact table to that dimension table and return the product name if I want to. So the fact table just holds keys and then your measures, right? Your facts. So you have your fact here, sales amount. This is your fact here, right? Sales amount. So if I want to know for this first row now, for example, right? What was the products that was sold, right? This product key will be linked to the product table. So I can leverage that connection and return the product name. I don't have to put the product name in this table, right? So you see that this helps me to reduce repetition. So let me clear all this. And now let's look at a denormalized table, right? So if your fact table, for example, stores details beyond the key, so you have repetitive values, right? Then that's considered to be denormalized. So look at this image, right? You see that what's unlike the previous image, right, where you had just product key. This table, you now have all the information about the product. So 594, the first row, 594 product key, right? It refers to the product called Mountain 500 Silver, category bikes, color silver, size 38. This table now is normalized, right? So if I want to update a new row, for example, I'll have to update the sales order number, order date. I'll then update all the product information, right? But this other example here, just the product key, that's all, 595, for example. I can then look that up on a dimension table and return whatever product attribute I want to return, with product name, product category, etc. But this table here, right, everything is in one table. And the downside is that all these columns, right? So the thing here is that facts, right, they have more rows, right? So example, picture a scenario where you have an organization that sells products, for example, they sell products, right? So a fact is when a customer buys a product, right? So every day customers would buy products, right? So if you're tracking all those orders, you have several rows. So look at 1 year, 2 years, 10 years, you have several rows. All those orders being made, the orders, the sales amount, the quantity, these are all facts. So you keep tracking all of them. You have several rows of data, right? And if in your fact table, you now have all those columns there, you have product, category, color, size, they will occupy a lot of space and it will lead towards low performance of your data model, right? So that's why it's best to have a normalized fact table. So compare where you have 10 million rows of this table and 10 million of this table. Is common knowledge, right, that this one here would perform better than what this one here, right? And add to that, there are columns that are like text. So product is a text column, category text. All those text columns, they occupy more memory than keys, than numeric, right? So it's best to build a model that has your fact tables normalized, and you now have dimensions for the product, right? So a dimension table, typically you can afford to have several columns because, for example, let's say I have a dimension for products. My company sells 500 products. That's all. It can't grow more than that. But your fact table can grow into millions, billions, right? And if you have several columns, then it will lead to very, very poor performance. So now let's look at relationships and cardinality. So in Power BI, relationships are based on common fields between tables. So this model here is a sample data set, right? Superstore data sets. And let's look at these two tables, the customer table and the orders table, right? So here, I can filter the sales amount, right? The sales amount, I can filter this by customer name, for example, right? how I establish a connection between common fields, which is customer ID on the customer table, this, and customer ID on the others table. These are similar fields. Once I connect them together, I can then filter sales, for example, by customer name, even though the customer name does not exist in the others table, right? But because I've created a connection, this is similar to a primary key for any connection. Once you have that connection, you can then filter these tables, right? And they will act as if they are just one table. So these relationships and Power BI, right? You create relationships between common fields, similar to your primary key, foreign key connection. Now let's look at cardinality. This refers to the relationship between two columns in a table. So you create connection between common fields, right? But then there are different ways these connections can occur. So the first type is one-to-many or many-to-one. The other one is one-to-one, and the last one is many-to-many. So let's this is an example of a connection, right, in data model in Power BI, and you can see this boxes in red, right? It's showing you the cardinality. So this example is showing you a one-to-many cardinality, right? So this one, it means that what you have unique customer IDs in this table, right? This one is showing that what this customer ID field, they are all unique in this table. Why this star many is showing you that what you have many occurrences of the customer ID in the others table. So this is like your primary key, this is your foreign key, right? You can connect them and then filter your data. So let's look at all this one by one. So the first one is one-to-many or many-to-one. So they are the same thing, right? One-to-many, many-to-one. If you flip the direction, they become the same thing. So for one-to-many, it exists when one row in a table can be related to multiple rows in another table. But the rows in the other table are only related to one row in the first table. So if you look at this example here, right, when you create a connection between the customer ID fields in both these tables, so you have the first table, this is your customer table. It holds information about this table here, right? It holds information about customers. So you can see information like customer ID, customer name, customer email, gender, birth date, right? And then the second table here, this holds information about orders. So this customer at this postal code bought this product. This is sales amount, this is a quantity, etc. Right? So this is like your facts table, and this is dimension table. So for this example, right, you can see that the first table has just one occurrence of every customer ID. So you have in red AA 10315. That's just one customer. And this customer ID, they are all unique, right? You have only one occurrence of every customer ID. On the second table, you find out that what that same ID, AA 10315, right? It occurs several times. So this is an example of what one-to-many, right? One ID in the customer table occurs many times in the others table. And that's what a one-to-many connection. So this is typical, right? When you try to understand what's happening, this first ID, AA10315, that's Alex Avila, right? He can buy multiple products on different days on the same day, right? So all those rows here, all those rows on the orders table is just showing you what different times, different orders that were made by this customer, right? But then on the orders table, you have just one occurrence. You have just one occurrence, right? Just one occurrence for that guy. I can't have this row occur several times. This row just tells me that this guy, his name is Alex Avila. This is email. He's a male, right? This is birth date. So if, for example, I want to find out all the sales that are made by this guy, right? I'll just link the customer ID here to this customer ID here. And I can use the name, right, to show all the sales that are made by that guy. So this is how it works in Power BI. So let me clear all this. This is an example of a one-to-many connection. And this is the most common in Power BI, right? One-to-many, many-to-one. And this is ideal for a star schema. So you have one-to-many or many-to-one relationships. And this is what you try to achieve. Then the next one is a one-to-one cardinality. So one-to-one happens when you have unique values in both fields. So both fields contain the same values and they are also unique. So in my data set, right, let's say I duplicate the customer table and I have two customer tables, the exact same table, right? So if I link the customer ID together, you have what? One-to-one connection. So for every customer ID that occurs once, it also occurs once in the other table, right? That's a one-to-one. So you have one occurrence each of the field in both tables. And most times, right, this kind of connection is recommended to just join both tables together. So if for any reason you have tables that are connected one-to-one in your model, you just join them together. That's the recommended approach instead of having a one-to-one connection, since they are both the same thing. Then the next one is a many-to-many relationship. So this exists when you have multiple rows in a table that's connected to a different table, right? So you have multiple rows in a table and they relate to multiple rows in a different table and vice versa. So for this example, right, I duplicated, okay, if you look at the bottom table, right, you have region, the last column, right? If you link region and region together, but that's not the ideal way to link them, right? The ideal way is to use the zip code, zip. Those are unique. But then for the location table, the region column has duplicates, right? You can have multiple zip codes in the same region. So you have duplicate regions here. And if I link this to the others table, right, you see that what it shows me a many-to-many cardinality because I have duplicate regions in both tables, right? And this is recommended to avoid this kind of connections as much as you can in your models because it leads to data inconsistency and it's very difficult to understand how the different tables are interacting with themselves. So it's best to avoid many-to-many relationship. But there are some scenarios where you might have to have this kind of relationship, right? And then you have what's called a bridge or junction table. So that's used to link them, but we won't go into that in this section. So that's a many-to-many relationship. So now we've looked at all of the concepts, right? In Power BI, data modeling is very, very critical in your workflow. So a typical workflow involves connecting to your data, right? Using Power Query. It could be a database, an Excel file, a website, etc. Once you've connected to your data, you then transform and clean them up, right? The next step is to model your data. So you have different entities, right? Different tables. You connect them based on their similar fields. You create your model, right? And in most instances, you might have to create, using DAX, you create measures and calculated columns. Once you're done with all that, the next step is to now start creating visuals, right? So you create your reports. And once you're done, you then share your reports or dashboards with your colleagues, right? So you publish it to the Power BI service where it's shared. So you see that data modeling is very, very critical, right, in the whole workflow. So let's see a demo, right? For this section, we'll try to go from a denormalized model. So on the left-hand side, you have the normalized table, right? Superstore. All the columns are in one table, right? And like we've seen, this is not advised, right? It leads to very, very poor performance. This can work when you have small data, but as you scale up to millions of rows, billions of rows, it will become impossible to maintain this structure, right? So you have to transform it towards an optimized data model. And a star schema, right, is recommended for analytical purposes. So on the right-hand side, you have a star schema, right? So I've transformed this normalized table on the left-hand side to a star schema. At the center, you have the orders table, right? The fact table, and you have dimensions, location dimension, date dimension, customer dimension, and product dimension. So let me open up so I'll open up a new Power BI. Let me just close this. So I'll open up Power BI. Next up. And while this coming up, let's look at the data we're working with, right? So this Excel file here is showing the normalized table, right? This is a table that has all the columns. So you have order ID, order line ID, order dates, ship mode, etc., down to the profit, right? So our goal is to transform this normalized table into something like this, right? So here now, you're able to create a fact table that's normalized, right? So you can see we've taken off all those dimensions, the customer name, for example, location, they're all out, right? And we've now put them into their own tables. You have a customer table, you have a location table, and you have the product table, right? So let's see how we can do that using Power BI. So this is my Power BI desktop, and I'll connect to this file, right? It's a CSV file, an Excel file. So get data, and using Power Query, I want to connect to text or CSV file. So I'll choose this option, test CSV. And this is my file, right? Superstore.csv. So I open this up. So this is a preview of my data. I can see it looks accurate. Order ID down to profit. So as in most scenarios, right, you want to transform your data. So I'll click on transform data, and this should open up the Power Query editor. So it's always great, right? Before doing data modeling, you have to have like the end result, right? What it would look like, your end result, right? So from this slide, right, you can see what the end result would look like. We want to have an orders fact table connected to what? Products dimension, location dimension, date dimension, and customer dimension. So using this, right, this will be my guide in my design decisions. So here I have the normalized table, right? Order ID down to profit. So I want to make a new table, right? So I'll come onto this query here, Superstore. This is the table, right? I'll come on here, I'll do a right click, and I'll just duplicate this. So just copy it, right? Duplicate it. And this Superstore, right? I want to have all the fields for let's start with let's start with customer. So this will have all the fields for customers, right? So any column that does not have customer information, I'll take it off. So I have customer ID. I have customer name. So I'm holding control, right? Control. I choose customer ID. I hold control. I choose customer name, customer email. I want to just retain all the customer information columns. I have customer gender and I have customer birth date. These are all columns, right, that pertain to customers. They are all attributes of a customer: customer ID, name, email, gender, and birth date. So all the other columns, right, they relate to other attributes that are not customers. So I'll ignore them. So I choose these columns. And what I'll do now is I'll right click and I'll choose remove other columns, right? So I take off all other columns. And now I have just customer information: customer ID, name, email, gender, and birth date. So this looks good, right? But then you find out that we still have duplicates, right? These clear goods occurring multiple times. That we have duplicates here, right? But then for customers, right, every row should be a customer. We don't want duplicates. And on this table, right, the unique column or primary column should be the customer ID. Identifies all the unique customers. So I'll come on to customer ID. I'll right click and I'll choose remove duplicates. So I choose this, right? And it takes off all the duplicates. So now you can see, right, I have no more duplicates customer names here. They're all unique. So this looks great, right? I think we've successfully created a customer dimension. And now I can link this table, right, to my fact table. Customer ID is here. I also have customer ID, right, on this table when I scroll. So I can link these tables based on the customer ID. This is unique, but this table can have duplicates, right? Duplicates customer IDs. So I can create a one-to-many connection. So I'll rename this query. I'll call this query customers. So I have the customer dimension. Let's look at another entity we can extract. So what I can do, I can, you know what, let's get the next entity. So I also have entities. I have attributes of location, right? So you have the country, the order was made, the city, the state, the postal code, the region. These are all entities, right, of location. So cell attributes of location rather. So I can also extract this to make a location table. So I'll choose the country, hold down control, city, state, postal code, and then something else. So country, city, state, postal code, and lastly, the region. These are all location attributes. So I do a right click and so apologies. I need to duplicate this first, right? So duplicate this also. And on a duplicate, that's where I will remove, I'll do my transformation. So I hold down control, country, city, state, postal code, region. These are all the location attributes. So I right click and remove other columns. I don't need this also. Remove this also. So I have country, city, state, postal code, region. So the next thing is, right, identify what is the granularity of this table. So how do you what field will be your unique identifier? In this case, right, it can be country, it can be city, it can be state, it can be region, right? So what would work best is the postal code. So I'll take postal code too. the first row here, and I'll just do the same thing as the customers table. Do a right click and remove duplicates. So now I have a unique table, right, that shows all the different postal codes, their countries, the city, states, and the region for every postal code. And I can also link this right to my fact table using postal code to postal code. So one thing I'll do is I'll change this postal code to text. So the reason is because it's possible to have postal codes that start with 0. So 0, 1 something, for example. If you change to numbers, that first 0 at the front will go off, right? And that will change the meaning of that column. So you can't join with other columns again, right? So I'll just change the text, replace current. The same thing here too. I will change postal code to text also. And just do that here. Change type. I'll change postal code to text. Change to text. So we've taken out duplicates and this looks okay, right? I can rename this. I'll call this location. And the next entity we can make a table for. So we've done for customer, we've done for location. We can also do for product, right? So product attributes, you have product ID, you have category of product, subcategory of product, the product name. You also have the product segment, this, right? So you can also extract this and make a table for it. So I hold control, click on segment. I come on here, hold control, click on product ID, category, subcategory, and product name. So once I have all these, I can, I always skip this. So first of all, right, we'll make a duplicate of this query. Apologies. This is our original query, right? We'll duplicate it first. And then we'll extract the columns we need. So I start with segment column, click on this, and I scroll, hold down control, product ID, category, subcategory, subcategory. And lastly, the product name here. So I right click and remove other columns. So segment, product ID, category, subcategory, product name. So the next thing, right, what's a unique identifier of this fields? That's the product ID. So for every product, we want to know the segments the product belongs to, the furniture, the category rather, subcategory, and then the product's name. So the ID, right, will be the unique identifier or your primary key in this case. So I'll just put this at the first column, just design preference. I would like to have it in the first column. Then I come on here, right click, and also remove duplicate. So now I have a product table also. I'll call this product. So I have customers, location, products. So it looks like we're almost done, right? But then it's always important to also have dimensions for your dates, right? So date dimensions. So it might seem like it's irrelevant, but it's very, very important in your model to have a dimension for dates. And this is useful in scenarios where, so different companies, right, report dates in different, you have fiscal years, you have different ways of calculating things like a week year, right? Or holidays and stuff like that. So data modeling would help you, right? If you have a data table, you can use that to do those custom calculations very, very easily and efficiently. So it's best to always have a date table a date dimension table in your model. So for this, right, we have other dates, we have ship dates. So what I can do is leveraging what we did in the Excel Power Query section, where we use Power Query to make a date table. The same thing I'll do here also. So first things first. So I want to make a before that, let me just highlight something, right? So order date, right, comes first before shipping date. So a customer will make an order, right? Maybe today, for example, it might take maybe 2 days or 3 days or more to ship that product out, right? So this comes first, and then shipping date comes next. So that would be important in a bit. So I want to make a date table using the earliest order date and the latest ship date. So what I'll do is I'll come on to new source. New source. I want to extract the earliest order date. So I'll choose a blank query. So here I would write this formula. Date to start of year. So this extracts this first day of the year for a particular date, right? And here I'll pass in a formula list dot mean. So here I want to extract the minimum date from the orders table. So here I'll pass in the this superstore, as I call it, superstore table and the order date column. So let's see what it gives me. Enter. So this gives us the 1st of January 2014, right? So just to confirm something, this is the superstore table, right? I'm working with the order date column, right? So when you come here and look and just scale, right? The earliest date is what? 4th of January 2014, right? That's the earliest date. But my formula then returns what? The start of the year. So this query here, list on mean, right? It returns the earliest date, which is January 4th. This query then takes in January 4th as the argument and returns the first day of the year, right? That's 1st of January 2014. That's what this does. So I'll call this stats. And then I'll just duplicate this. And I'll just make a slight edit. So I want to return, instead of start now, to return the end. The end. And then instead of mean, I want to return max. And instead of order date, I'll just use the ship date. Okay. Since I understand that the ship date comes after the order date, right? I'll just use this. This returns the end of the last day of the year, right? In the ship date column. So 31st of December 2018. So this is I'll call this end. And then I would use this now to make my table. So new source, a blank query also. So this looks complicated, right? But if you just attempt it once, twice, you get the hang of it. So equal to, so for this, I will just use a simple formula, number dot from. So here I'll pass in this the stats query we just created now. Stats. So I'm saying I'll put in 2 dots and the same thing, so number dots from in brackets the query we just made now, right? That's end. So I'll put the end query here. So what I'm saying is use the task query, right? That this create a list of numbers from this task query, make a list of numbers to the end query, right? So from the 1st of January 2014, make a list of dates till the end date, which is what 12/31st 2018. So I enter here, right? And it gives us a list, but it's showing as numbers. So what we can do is this is a list. If you look at the top left, you see what's to table. So it means convert this list to a table. So I'll choose that option to table. And it should return a table, right? I hit OK. So this is my table, but it's currently not a date. So I'll come onto the data type here, click on this and choose dates. And you can see, right, the start value 1/1/2014. That's the first day, right? And if you look at the very, very last day, it's not showing me that. Okay, let me just change the sort descending. So you see that the last day, right, is the same thing as what we have here, 12/31/2018. That's the last day. So I just made a list of dates from that start date to the end date. So I'll call this dates, right? This column will be date. And I can make other dimensions. So a date table, right? You have things like what's the year, what's the month, what's the week, etc. Right? Those are dimensions I can make. So I'll just come on here, right? In Power Query, to make new columns, you click on the add column field, right? Add column field. So this is selected, this is a date field, right? So I'll come on to this dates option here. This date option here, I'll come on here, right? So from this column here, this date field now, extract the year. I choose this, right? And you see, extract the year, right? This 2014 year, right? Same thing, so I'll click on this column, come here also, extract the end of the month. And you see what it extracts end of the month, right, for the date field. Same will also extract the quarter of the year. This quarter 1, right? And you can see 1 to 4. And let's do one more. So I can extract, okay, let's do 2 more. What do we call the year? Let's extract that week of the year. It should be 1 to 50, 52 or 54. And then let's do one last one. So I'll extract the day, the name of the day. Is it Monday, Tuesday? So I'll extract that also, right? This is my date dimension. So one thing I can do is this queries, they are helper functions, right? They help me to make my dates, but I don't need them in my Power BI model. So I'll come on here and disable load. So I'll click on this option, right, and disable it. So you see, now in italics. Same thing here. So I'll come on here and disable load also. Click on this, disable load for this. So now I have my dimensions: customers, location, product, and date dimensions. So now, right, my fact table, I can remove all those dimensions that are here. I can take them off. So for some reason, let me see. Time is fast spent. I'll just take this off also. So I'll take this off also. I will assume that I don't need this for my model, right? But then, you know what? It's important. So let me do one more thing, right? So let's say I want to make a dimension also that shows the shipping mode and the priority of the order that was made, right? So I'll duplicate this. I just do this quickly, duplicate this, and shipping mode for that priority. I remove all other fields, remove all other columns, right? So this is mode, this is the priority. So what I can do is I'll choose both of them. So I want to have, for second class, I will have medium, low, critical, and this, right? The next type, I'll have those folders just like that. So all of these, I'll click on these 2 columns, right click and remove duplicates, right? So I have 20. Yeah, cool. So second class, I have medium, low, critical. And this I have just like, yeah, exactly what I want. Cool. So what I can do is I can introduce an ID field, right? There's no primary key here. These are all dimensions. So in Power Query, you could just come on here, add column, and you can add an index column, right? This just starts from, it can from 0, from 1, or a custom column, right? So I'll just do from 1. So make an index column starting from 1. Click on this, right? So it makes index columns, right? That starts from 1 till 20. So I'll just drag this as the first column. It should be like my primary key for this table. So I'll call this ship priority key. Yeah, cool. So when you see 1 here, it refers to second class medium. When you see 2, second class low, right? In the same vein, when you see 20, same day low, just like that. So I've been able to make this right. But this key does not exist in my superstore table, right? So how do I link this? So let me call this this table. I'll call this shipping priority. Cool. So this is a dimension, right? It shows me the shipping mode and the priority of the order made. So this table now, how do I link it to my fact table? All those dimensions, customer, date, product, location, right? They all have keys in this table. For this table I made now, there's no shipping priority key in this table. So how can we achieve this, right? So this is where we leverage joins, right? So joins, and in Power Query, they're called merges. So what I'll do is I'll click on the superstore table, right? I'll come onto the home tab. At the top right, you have merge queries. So I'll come on here, right? And choose merge queries. So it means you're trying to do a join. It can be a left join, right join, and those SQL joins, right? Depending on what you choose. So I'll click on merge queries. Merge queries. So here, right, I want to add the shipping key from this my new table, shipping priority. I want to add that key to my superstore table. So I'll come on here and choose shipping priority, right? So you choose the columns you want to match by. So I want to match by ship mode. So 2 columns, hold control, ship mode and priority, 2 of them, right? Match them to this column also, ship mode and priority here, right? So match them by it. And what I'll do is a left outer join. So it means that what I'll retain all the tables, all the columns in this my left table, right? Superstore. And I'll just add the matching column from what the shipping priority table, my right table, right? So I'll have this right left outer join and I hit OK. So this is my superstore table, right? And it shows this option. So it means that what I've successfully joined together, right? I can now try to choose the column I want to add to this superstore table. So when I come on here, right, this icon, I'll click on it. And I don't need the shipping mode. That's already in this table. I need priority. I need just the priority key, right? So I can join them together in my model. I want to check this and hit OK. And you can see, right, I've been able to bring in the priority key to my facts table. So I'll just put it somewhere here. That's somewhere here. Somewhere here. So 1 is second class medium. Let's check if that's correct, right? There's 1, second class medium. And what's 2? 2 is second class low, right? Let's see if that's correct. So this is 2, right? This is 2 here. And you can see what second class do, right? 3, critical. Also, you check everything, right? They all match with the priority key. So that makes sense. So I've made all my dimensions, right? So in this table now, I can remove all those dimension fields. Since I have the keys, I can join them with. So I'll come on here. I don't need the shift mode. I don't need the priority also. I don't need the customer name. I already have that in my customer table. Oh, no. Customer name. So I hold control, email, gender. I have all these in my table already. I don't need them. I'll come on here. Gender, birth date, segments, country, city. Obviously, I'll check shift mode priority. So all those dimensions, shift mode priority, I don't need them. Customer name also. Yeah. I hold control. Just choose all dimensions. I don't need all this. I already have them in my dimension tables. Just the keys are left here. So I don't need region. I don't need category. The product ID was linked to the product table. Postal code links to the solution table. So I'll leave them there. They're my joining, they're my connection keys. I don't need these also. So I remove everything, right? Remove columns. And here, right, I have my I have my normalized fact table, and I'll call this others. So this is my normalized orders table, right? I've removed all those dimension columns, and this will make my model more efficient and eliminate redundancy. So imagine a scenario where a new customer comes into the company, right? I'll just come on here and update the information, his name, email, gender, birth date, and that's all, right? But in the original table, right, you have to update information in several fields, right, at the same time. Or maybe a customer changes his name, you have to go back in time and replace all those instances and stuff like that. So all those would lead to a lot of strenuous work. So I have my fact table, orders table, my dimension, customer location, product, date, and priority. Once I'm done, right, it looks all good. I can come on here and close and apply this. So these applies all my changes to Power BI. So you can see this is applying my changes that I made. So one thing to note, right? Power BI will try to depending on your settings, Power BI will try to detect the relationships between your tables, right? But you can change the settings if you want to. So if I come onto my data model, right? Data model, that's this third icon here, right? This icon here, data model. If I come on here, data model, you can see that let me just I can come down here, the bottom right, and click on this to auto fit the tables, right? So this is what my model looks like. So this is task schema, right? All the dimensions are connected directly to the other table. And just yeah, cool. So you can see that Power BI detects most of the connections, right? Because of my setting. So if you most times, right, it might be accurate. There are times where Power BI make mistakes. So it's good to always cross-check it. And if you don't want to have this setting, right, you can come onto the file option, come down to options and settings, options. And when you come down to data load, I think it's coming up. When you come down to data load down here, data load, you can uncheck this option, right? To import relationships, data sources, right? And this also, you can check it if you don't want those settings, right? So that way you manually make your connections yourself. So I'll just cancel this. So I'll delete these connections, right? I come on here, delete this. I'll do it myself. So let's assume that we've put in our tables, right? And we want to now make our connections ourselves. So I'll just delete all those connections and do it myself. Yeah, cool. So products and orders, right? From our diagram, products is linked to orders, right? We have the product ID. So I'll come on here and just click on, right, this stuff is small. Let me zoom in. So I'll come on here, right? Click on product ID and drag it to product ID in that table. And you should create the connection, right? And you see it's a one-to-many connection, right? So unique products, and you can have multiple IDs in this table, right? The same thing, customer orders, right? So customer orders, customer ID. I will drag this to customer ID here. And if you don't want to drag and drop, you can use this icon here, right? So I click on this icon here at the top of this page, and you can make your connection here, right? So I know that dates and orders, right? They are connected by what? The date fields, dates and other dates, right? One to many, hit OK, right? Add a new one also. So I know that location and others, right? They are linked by postal code. Yeah, that's correct. I hit OK. And what's the last one? Date, location. So product, date, location. Okay, last one is the shipping priority. So this and others, right? They are linked by shipping key. I hit OK. One to many, that's accurate. So I close this. And you can see, right, all the connections that are made. And this is a star schema, right? So you have your fact table in the center, and you have the dimensions. They are all directly connected, all connected to the table here. So using this, right, I can come onto the report view and make a chart, for example. So I can put a chart and say, make a bar chart showing so location, showing region. So I'll put region here on the y-axis, for example, and I'll put from my facts table, right, the orders table, I want to see the sales by region. So I'll put sales here on the x-axis, right? And you can see this shows me the sales by region, and it looks accurate. I want to put data labels on. Yeah, cool. And quickly, let me just do something quickly. Values, display units, 1,000. Yeah, so this shows sales by region, right? So I can see West has most sales, followed by East, Central, South. But if I came on here to my model and deactivate the connection between location and others, for example, imagine they are not connected in my model, right? The tables won't be able to speak to each other. So you see that it's showing what? The same value, across all the regions, right? Because there's no relationship between them. But once you put the correct relationship, right? Postal code connected to postal code, you find out that what Power BI can now detect the relationship between them and shows the accurate table, right? So I want to show something quickly. So let's say I have a new report, right? I want to connect to the original table, the normalized table we use for our modeling, and put the same chart. Let's see if we have the same results with what we have here. So it's me trying to validate my modeling if it's accurate. So open a new Power BI file, and here I would get data. So I close this. So I'll get data from a CSV file. Yeah. So this is my file, Superstore CSV. So I open this up. Superstore CSV, open this up. So I'm trying to connect to the original file, right, without doing my modeling, and put the same charts and see if it's accurate or not. So it's connecting to the original file, and it should pull up the navigator. So I think this looks clean. I'll just load this into Power BI, but that's not best practice. It's best to always transform and cross-check. But I think it looks clean. So I'll bring it to Power BI. So this in Power BI, and if I come onto the data model, this is my table, right? It has all the fields in one table. This original table without any transformation. So it has all the fields, right? So I'll come on here, right? The exact same chart we just made now. I'll put a bar chart also. So here I'll show the same thing, sales by region. So I'll come on here, I'll bring in region on the y-axis. I'm bringing sales here, right? Data details on varies 1,000. So you can see, right, the exact same figures, West 725.46. So our model looks accurate. The downside is that for this table, right, once you have billions of tables, of rows rather, you have very, very poor performance. So it's best to make a data model, right? A star schema preferably. So we are able to go from this, right? One table. We went from this to this, right? A star schema model that returns accurate visuals and results, right? So that looks like a job well done. So we went from a normalized table to a star schema. So quickly, let's look at best practices for data modeling, right? So the first thing, right, is to start with the end in mind. So it's always best to have the end goal in mind, right? And that should guide your modeling steps. So you do a kind of reverse engineering. You go to the end of what it should look like, and then work backwards, right? And try to use the data model end goal to guide your decisions and steps. Then the next is to use a logical and intuitive model. So a well-designed model should be easy to understand and navigate, right? If you see our example that we made, right? Just keep looking at the model, you can tell, right, how the fields are connected. So these orders location, they are linked by postal code, right? Product orders, they are linked by product ID, etc. So easy to understand and navigate. So you should try to have a logical and intuitive model. Then next is a star schema. So star schemas are easy to understand and they offer optimum performance for reporting. So always try to work towards a star schema and use data type appropriately. So for this, right, ensure that for a date field, you have a date type. For sales, for example, you have numeric type. For text, you have a text type, etc. So use the types of data appropriately and use proper naming conventions. So don't use abbreviations that are hard to understand, right? Use proper names that are easy to understand. And then next, use roles to control access to data. This is a bit advanced, right? But data model is useful so that you can ensure data security. So for example, there's what we call role level security in Power BI, whereby you can specify who has access to what data, right? And data modeling helps you achieve that. And next, right, use calculated columns and measures judiciously. In our next section, we'll look at using DAX to make measures, right? And while these can be useful, if you use it too much, it might impact your model performance. And the last tip is to test and optimize your model. So hopefully in subsequent sessions, we'll look at how to check the performance of your models, right? But then it's always good to, over time, you test and look for ways to improve the performance of your model. So at this juncture, are there any questions that anyone might have? You could type in the chat or raise your hand for a roundup. So if you have a question, you can type in the chat or raise your hand. It looks like there are no questions. I guess that means we understood what I was explaining. So thank you all for your time and have a great night's rest and an awesome week ahead. I'll catch you guys in the next section. Good night, everyone.
Thank you for the session, Abina. Good night, everyone.
You're welcome, Chisholm. Good night.